Hello, am I audible? My dear students, am I audible? Hi, Dr. Spark, Nisha. Good evening. We are going to start now. So, as you people told, sir, bring that chapter thermodynamics. So, I'm going to start that today. Calorimetry. After that, we'll move to the thermal expansion, then thermodynamic processes, and that heat transfer. There was echo of my on mobile. Yeah. Yes, I'm audible. Sir, is it possible to complete mechanics within NEET 2020? Okay, it depends ke how much like how much you prepared before, right? If you think from zero you'll start, so I don't think it is possible because you need to handle other subjects also, right? But nothing is impossible. Okay. Yeah, so let us start. Okay, so my dear friends, welcome to Unacademy. Unacademy is the India's largest learning platform where you can prepare for the various competitive exams with the help of the top educators of the country with the quality content and great learning experience. And I am available here to help you to crack NEET UG. So let's crack NEET UG. Let me introduce myself. My name is Rahul Dagariya. I have been teaching physics since 5 years in the various non institutions of India. Till now, I have mentored to the thousands of aspirants of NEET and IIT JEE. I'm BTech from NIT Rourkela. Yes, I am an engineer from National Institute of Technology Rourkela. And now, I am available here to help the students of the country to learn the concepts of physics for NEET UG. Okay, so next, I will talk about our motto that is called a new anthem. We want you to crack NEET UG with the India's largest learning platform, Unacademy. We want you to crack NEET UG with us. So, for that, if you really want to crack NEET UG, get the plus subscription and access to the unlimited lab and recorded courses from the India's best educators. Yes, Unacademy will provide you the India's best educators. If you did not download the Unacademy app yet, go to Play Store and type Unacademy Learning app and download it. There you will get many facilities. Okay, so there are some special lectures also which are free for you. So definitely there is no loss in downloading Unacademy Learning app. What you will get if you will buy the Unacademy subscription? So you will get the daily live classes. You can see here on YouTube. I'm just providing a live class, but it is just a random topic, right? It is not in a structured way. Just random topics I am bringing in front of you. Yesterday it was vectors, right? Just one lecture of vector, right? And remaining topics are remaining only. Okay, but today it is thermodynamics. Okay, so I'm just saying ki if you want structured courses, so you need to download the Unacademy app. Okay. So daily live classes. During the live classes, you can chat with us. You can engage in discussions. You can ask your doubts. You can discuss the answer post, and you will have a lot of fun. Okay. So I think you might have uh, attended the special classes on Unacademy app. So definitely, it is very good. You will enjoy with me. So next is live tests and quizzes. You can evaluate your performance with a regular mock test and quizzes, and you will get its detailed analysis how you are performing, in which concept you are good, in which concept you are not good, like that, right? So you will understand where you are standing. Okay, so tests and quizzes are very important to evaluate your performance and to show you the mirror. Okay, so structured courses. So next I will talk about, yeah, so next I will talk about the structured courses. Structured courses means I'll say you'll get the entire syllabus physics, chemistry, and bio. Bio include both zoology and botany, right? So if you buy the Unacademy subscription, you'll get all three subjects, entire syllabus by the India's top educators. Okay, and you will enjoy it, and everything will become very easy for you. So many times students don't know after one completion of one topic which topic they should start. But here the Unacademy professional means the educators will guide you very well. Okay. So next, unlimited access to the live and recorded courses. Once you miss the lecture, you know, then you can watch its recording and you can watch it again and again at repeated mode until you did not understand that. So I'm saying ki it is beneficial only. Okay, so our free live classes are available on YouTube and Unacademy Learning app. Those are some special classes. Okay, so just experience some special classes. You will enjoy it. Okay. Next, I'll talk about our top educators. Our top educators are mainly from IITs, NITs, reputed MBBS colleges, AIMS, etc. So I can say they are very experienced. They have produced very good ranks. So देर किस बात की आगे बढ़ते हैं so next I will talk about yeah next I'll talk about our subscription, right? So our subscription, you can see our subscriptions are available here for 1 month, 3 months, 6 months, 12 months, right? So yeah, I'm taking laser. You can see 1 month subscription is available for 6,000 rupees. But if you use my code Rahul D, keep it in your mind, Rahul D. If you use this code, then you will get it for 5,400 rupees. After that, directly I'll talk about 12-month subscription. If you buy it, okay, its fee is 30,000 rupees. If you buy this, you'll get it for 27,000 rupees. Okay, and if you buy it for 24 months, yani ki 2 years, then you will get it for 32,400 rupees if you use my code Rahul D. So remember this code. This is very, very important, very, very useful for you. Yeah. So why I am not able to take this pen? Just a minute. Yeah. Okay, whatever. Let's see. So here I'm talking about this, right? You can see which subscription is beneficial. So you can see just 27,000 rupees means equivalent to 5 months fee, right? So definitely, if you are appearing for 2021, then you should buy what 12 months subscription. And if you are appearing for 2022, definitely you should buy 2 years subscription. Because in 1 month you cannot cover entire syllabus, but in 1 year or 2 year definitely you'll cover entire syllabus. Okay, yeah, definitely I'll reply your queries. Okay, so let me talk about this. Just a minute. Why I'm not able to take this pen? Why this pen is not working? Just a minute. Just a minute, my dear friends. Why this pen is not working? I'm not getting. Laser is working. Yeah, tomorrow same chapter. Okay, today we'll complete the calorimetry, but just wait a minute. There is some technical problem. I'm not getting what's the problem. So just a minute. Okay, just a minute. Just a minute, my dear friends. Let me check what's the problem. I'm coming back. Just a minute. My dear friends, there is a technical error. Just a minute. Let us solve it. Okay. Yeah. Now it's working. Okay. 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 So, my dear friends, let us continue. Yeah. Yes. Okay. Yes, my dear friends. So, yes, clear. Everything okay now. So, let definitely you might be facing a problem. Sorry for wasting your time, but it was a technical error. Yeah. So, let me check your comments. What you want to say? Increase the video frequency per day, please. Okay, per day video frequency I should increase. Okay, yes. Next, will full syllabus be covered free of cost here on this channel? I can't say whether I can cover the entire syllabus on YouTube or not, but on Unacademy app definitely I can do that. Okay, so will you continue the chapter tomorrow also? Yes, I'll continue this chapter. Entire thermodynamics I'll take. Okay, will full syllabus would be covered. Yeah. So next. According to NCRT, sir. So teach according to NCRT. Okay. Definitely I'm teaching according to NCRT. Means according to NEET I am teaching. Okay. Yes. So obviously it is NCRT based only. So let's move. Full syllabus. Okay, done. So only hope for the South Indian students for physics, sir. Definitely I'll try my best to help you out. Okay, my dear friends. Don't worry. Science magic's king. Okay. Yeah. Okay. So let's talk about this. So will you continue same chapter tomorrow? Yes, I'll continue the same chapter tomorrow. Okay. Yes, I'll increase the video frequency. Don't worry. Okay. Yes. So let us continue. There was a problem, technical error, right? That I was not knowing why it happened, but now it's okay. I understood what was the problem, right? So let us talk about our today's chapter. That is calorimetry. Okay. So today I'll cover calorimetry. Tomorrow thermal expansion. After that thermodynamic processes, yani ki thermodynamics, and last chapter will be the heat transfer. So I'll cover the entire topic, and this is very important. Okay. Uh, 3 to 4 questions generally used to come from this chapter, means entire thermodynamics. Okay. So this is an important chapter. You cannot ignore it. Okay. So let us talk about this calorimetry. Okay. What is calorimetry? Calorimetry is the branch of physics which study the change in temperature or heat. We can say which study about the heat, right? Yeah, so that is calorimetry. We'll talk about it in details. So let us move. Yes. So at first, let us talk about heat. What is heat? Heat is just a form of energy, okay, which transfer from one body to another body due to temperature difference. Let's say I have two bodies, body A, body B. Body A is having temperature T1, body B is having temperature T2. Okay, but T1 is greater than T2. Then the energy will flow from higher temperature to lower temperature. So this energy in transit, okay, this energy in transit is called heat. Okay, so this is a simple thing. This is a simple definition I wanted to explain you, right? So the energy that is being transferred between two bodies or between adjacent part of bodies as a result of temperature difference. So I already told you the heat will flow only and only if there is a temperature difference. If the temperature of both the bodies are same, then the heat will not flow, because when the two bodies are having same temperature, they are called in thermal equilibrium. Okay, so whenever there is a thermal equilibrium, there will be no heat. Okay, if two bodies are having same temperature, they are called in thermal equilibrium, right? They are said to be in thermal equilibrium. Yes. So am I audible clearly? My voice is audible properly? Yes. Amazing creativity. You have written so volume. So my volume is audible to you? Yeah. It is audible. I can see. So, next, heat is a form of energy. As I already told you, it is energy in transit whenever the temperature difference exists. Okay. Yes. Once it is transferred, it becomes the internal energy. Yeah, very important. Once it is transferred from one body to another body, so it will store in form of internal energy. Okay. After that, it will not be called heat. It will be called internal energy of the second body. Okay. Got it? Just energy which is transferred, which is in transit, that is called heat. Okay, when heat is completely transferred from one body to another body, after that it will not be called heat, it will be called internal energy of the body. Okay, so whenever internal body energy of the body increases, the temperature of that body increases. Whenever the internal energy of body decreases, then temperature also decreases. Okay, so simply I told what, there are two bodies. This is body A, this is body B. Okay. Why I'm writing there? Yeah, body A and body B. Okay. So I'm saying this is T1, and this is T2, right? So T1 is greater than T2. Okay, so heat will flow, energy will flow from T1 to T2. So this is called heat. Okay, whatever energy will flow, that will be called heat. After that, when completely heat is transferred to B, so I'll say it will store as internal energy of B. That's it. This is the simple thing I wanted to explain. Yes. So here the same diagram I have drawn at the last slide. Okay. So when we say the body is heated, it means that is the molecules. Like whenever we increase the temperature of the body or we heat the body, what will happen? It is having so many molecules. You know, a body is made up of millions of atoms, right? So it is having so many molecules. So those molecules, right, they will gain kinetic energy because heat is what? A form of energy. Body will receive heat means body will receive energy. So where that energy will go? So that energy will go in form of kinetic energy of the molecules inside the body. So whatever you know, in a body, all molecules are having what? Random motion, right? They are having random motion. If we increase the energy, like we heat the body, what will happen? All molecules will run faster. Their kinetic energy will increase. Okay. Yes. So when we say that the body is heated, it means that the molecules begin to move with greater kinetic energy. Okay, remember this. If we increase the temperature of the body, what will happen? Its molecules kinetic energy will increase. Yes. So SI unit of heat is what? Joule. We all know that heat means heat is what? Energy. Unit of energy is joule. So SI unit of energy is what? That is joule. Okay, so joule, some used to say joule, some used to say joule. Whatever you feel comfortable, you use that. Okay, joule or joule. It's your wish. Another common unit of heat is that is calorie. Remember, calorie is also very important term because yeah. So most of the time you will get calorie or joule. These two terms you will get. Okay. So both are the units are very important for us. Okay. How to use it? I'll explain. Right. So I'll say 1 calorie is equals to 4.18 joule. Remember this value. 1 calorie is equals to 4.18 joule. So we can say it is approximately for the use of calculation. You know, to make the calculations easy, we use 4.2 joules, right? 1 calorie is equals to 4.2 joules. Okay. Yes. So what is the definition of calorie? What do you understand by 1 calorie? Okay. Yeah. So I will just talk about what is the meaning of 1 calorie. It is defined like 1 gram of water we took. Okay. 1 gram of water. Okay. We are increasing its temperature. Okay. We are rising its temperature 14.5 degrees Celsius to 15.5 degrees Celsius. Okay, we are just rising its temperature from 14.5 degrees Celsius to 15.5 degrees Celsius at normal temperature and pressure. Okay, sorry, at normal pressure, yani कि atmospheric pressure. Okay, temperature is rising from 14.5 degree Celsius to 15.5 degree. It is defined like that only for the specific range. 14.5 degrees Celsius to 15.5 degrees Celsius means rise of 1 degree Celsius. Okay, so that equivalent energy required is called what? 1 calorie. So I'll say the energy required. Okay, yeah, the heat required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius at 1 atmospheric pressure is called 1 calorie. Okay, this is the simple definition. Remember it, mind it. Okay, many times in options you will get this. Okay, yes. So yeah, here is the definition. I already explained, but once again, let us talk about this. Why I repeat again and again? Because it should completely like fix in your mind. Okay. So the amount of heat needed to increase the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius at 1 atmospheric pressure is called 1 calorie. Okay. Remember, mind it. So next I'll talk about the mechanical equivalent of heat. This is very important term. Mechanical equivalent of heat. What do you understand? Hey, mechanical equivalent is mechanical energy. Okay. So what is the unit of energy? Mechanical energy. So I'll say mechanical energy or work we can say. You know? So that is joule, right? So that is what joule. You all know. Okay. But what happened in starting, joule was not discovered. Okay, this unit was not discovered. People use this unit only, calorie. Okay, so definitely what happened is the amount of work. Okay, amount of work, okay, which is equivalent to heat, which is equivalent to heat, can be given like this. We can say amount of work that is equivalent to heat. So that I can say what amount of work can be given in, let's say, joule. Okay, or heat is what, H. So we will say W. W means work is equals to J into H. Directly we can say it is just what, it is just a factor which helps us to convert calorie to joule or joule to calorie. Okay, if work is given in joule, so we can convert in calorie. Okay, if heat is given in calorie, we can convert it in joule. Okay, so it is just what, very simple thing, W is equals to JH, and this J is called mechanical equivalent of heat. Okay, this J is called mechanical equivalent of heat. Okay, yes, so you need to remember it. That's it. This is a simple thing. Okay, I'm yeah, so I'll talk about its application. What is this, what is its value? Okay, yes, so directly I'll say the heat is equivalent to mechanical energy, we all know, right? And measured how much mechanical energy is equivalent to calorie. You know, how much mechanical energy, that is in joule, right? So that is equivalent to calorie. If mechanical work W produces the same temperature change, right? So I told you, right? Mechanical work W is equals to J. I already explained you. Simple. That's it. That only you need to remember. Okay. So you know one thing. What is the unit of work? That is joule, right? So that is joule. And after that, this is J, that is constant. And what is unit of heat? So that was used calorie. So we'll say what is the unit of this J, mechanical equivalent of heat, that is joule per calorie. This will be the unit of this. Okay, so we'll talk about its value and all, don't worry, I was just discussing its unit first. So, my dear friends, let us talk about this. Okay, where J is called the mechanical equivalent of heat, and J is expressed in terms of joule per calorie. So I told you its unit is joule per calorie. Okay, the value of joule is how many joules of mechanical work is needed to raise the temperature of 1 gram of water by 1 degree Celsius. So as I already told you, energy required to raise the temperature of 1 gram of water by 1 degree Celsius, right? Yeah, so 14.5 to 15.5. That is what? 1 calorie, right? So that is equivalent to how many joules, right? So that only what will convert it with the help of this mechanical equivalent of heat. Okay. So anyhow, you know the conversion factor. A is equals to what? Sorry, 1 calorie is equals to 4.2 joule. You know that means you know this also. So there is no difference. Same thing only. Okay. So directly we will say what? Yeah. Here the question is there for you. Yeah. What is the change in potential energy of a 10 kg mass after, yeah, after 10 meter fall? Let's say a 10 kg mass is falling from a height of 10 meters. So this is 10-meter height and a mass is falling like this. So we know one thing. What, let's say it is falling from here to here. So what is the work done by gravity? So that will be mgh, mgh, or we can say that is what, this is change in potential energy, we can say. So mgh is work done by gravity, and that is converting into heat. So W is equals to J into H, we can write. Okay, so now what we'll do, we need to convert it in calories. So at first let us put its value. So yeah, what is the change in potential energy of a 10 kg mass? So 10 kg mass, value of G is 10, H is also 10. So this is 1000. Okay, yeah, that is J into H. Okay, so we want to convert it in calories. So what we'll do, H is equals to, yeah, so what we'll do, this is 1000 joule and we want to convert it in calories. So what we'll do, just divide by J, and the value of J, what we'll write, that is, you know one, you know this. 1 joule is equals to 4.2 calories. You know that, right? 1 joule is equals to 4.2 calories. So you can convert it, right? So directly you will divide it with what? 1000 divide by 4.2. Okay, so you'll get it in calories. Are you getting, my dear friends? Okay, if you got it, please thumbs up. Okay, so in chat, please give a thumbs up if you got it. Simple, if you know the conversion factor means you know this. Okay. Yes. So nothing to do, just simple, whatever is in joule, you want to convert it in calories. So 1 joule is 4.2 calories, right? So you can convert it easily. So let us talk about the next thing, specific heat. Specific heat of a substance is equivalent to heat gain or released. Heat gain or released by the substance to raise a. Yeah. So next, very very important term, my dear friends, specific heat. Its symbol. At first, I'll talk about its symbol. It is represented by small s. Okay, small s. Specific heat. Okay, and what is the specific heat? So specific heat is just the heat required. Let's say I have a body. Okay, and its mass is unit, yani ki 1 gram. Let's say its mass is 1 gram. Okay, and I want to raise its temperature delta T by 1 degree Celsius. How much? Or yeah, so I just want to change its temperature by 1 degree Celsius. So whatever heat is required, that is called specific heat. So I will simply say the energy required or the heat required to raise the temperature of 1 gram of substance, yeah, unit substance of unit mass by 1 degree Celsius. Okay, so that is called what? That is called specific heat. So how to write it? Yeah, we'll study now. So let me erase it. So I'll say what? On the other hand, yeah, one more thing. If temperature is falling, then so definitely temperature is falling, then heat will what? Body will lose the heat. It will go out of the body, right? So directly we can write what? Delta Q is proportional to mass. Means whatever the heat the body is losing or gaining, that will be proportional. That depends on mass. So delta Q is proportional to mass. Means the heat gain or heat released is directly proportional to mass of the body. First thing you need to remember. Okay. Second thing, that is proportional to temperature, change in temperature. So let's say change in temperature is delta T. So I'll say the heat gain or heat release is proportional to delta T. These two things you need to remember. So combinedly, I can write it like this: delta Q is equals to m, sorry, proportional to m delta T. As we remove this proportionality symbol, we'll get a proportionality symbol. That is what? That is, here what will be that? Specific heat. So I'll write delta Q is equals to m. This proportionality symbol is S and delta T. So this S is only called what? This S is called specific heat of a body for a particular body. Okay. For a particular body, specific heat is S. Okay, like for iron it will be different, for copper it will be different, right? Yeah. So we'll talk about its dependence and all things. Don't worry. So S, I'll say S is equals to delta Q upon M delta T. Remember this formula also. S is equals to delta Q upon M delta T. This is the first formula. Delta Q is equals to MS delta T. You need to remember. Second formula is the same thing, right? Yeah. So here I told what Q is proportional to M, it depending on mass, right? And next thing, it is depending on change in temperature, whatever heat is needed at, right? Yeah. So I'll say Q is equals to MS delta T. Okay. Let's say if S is not constant, let's say the specific heat is not constant. Let's say its value is changing with temperature. You know, so in that situation, we'll write like this: PQ is equals to mass is always constant for a body, so mass M. Okay, S is variable. S is function of time. Let's say. So in that situation, I will just write S. Okay, and change in temperature dt. Because for small temperature change, we'll write dt. Okay. So I'll write Q. Okay, change in heat. Yeah, heat required or release. That will be integration of dq. So I'll write what? M S. Okay, and integration of dt. Right? From where to where? Initial temperature to final temperature. We'll write like this. So this is a simple thing. I think you can understand it very well, right? Yeah. So like that we'll deal and we'll find the heat released or heat required. Okay, my dear friends. So this is a simple thing. Very, very important formula. Delta Q is equals to MS delta T. Always we use this only. Okay. Yes. So let us talk about the next. Right. Yeah, the same formula I derived there where S is constant and is known as specific heat of a body. Okay. For a particular body, the specific heat is constant. That is, we can write Q upon M delta T. Okay. So here are some points. So SI unit of it, what should be that? we can write Q. Here you can see S is equals to Q divided by M delta T. Q is what? Q is called calorie. Okay. Mass is in grams, so I can write gram. And here, this delta T, that is degree Celsius. So I'll say calorie per gram per degree Celsius. This is what? This is CGS unit. Okay, this is CGS unit. If I want to write SI unit, so I'll write Q. Q is what? Energy, that is in joule. So joule per, yeah, mass is in kg in SI, right? And this is in Kelvin. The joule per kg per Kelvin. We can write like this in SI. Okay. So this is SI unit and this is CGS unit. You need to remember, my dear friends. Okay. Remember, mind it. CGS and SI units you need to remember. Always helpful. Okay. Next point. So specific heat of water, this value you need to remember always. You don't have any other option. So remember specific heat of water. You know, that is 1 calorie S water. Okay. S water we can write 1 calorie per gram per degree Celsius. Okay. Right. Yeah. So now what I'll do, I want to convert it in I want to convert it in what? SI unit. So I will multiply it by 1000, okay, in numerator and 1000 in denominator. So I'll get 1000 calorie, okay, divide by 1000 gram, right, per degree Celsius. So what can I write? So I can write here 1000 calorie means 1 kilocalorie, okay, 1 kilocalorie, and 1000 gram means 1 kilogram. So I can write what? Yeah, what I can write? Kilocalorie per kilogram per degree Celsius, right? Okay, up now I want to convert this calorie into joules. I know one thing, 1 calorie is 4.2 joules, so 4.2, right? Kilojoule per kilogram per degree Celsius. So here we can write what? 4200 joule per kg per degree Celsius. So here different things we can write, Hannah. Everything is same, only you just you need to know the conversion factor, how to do it. Okay, I think you are understanding. Okay, if you did not understand, give that wala smiley. Okay, you have that option, right? You can give that different wala smiley, confusion wala smiley. Okay, so give the confusion wala smiley here. Right. So let us talk about the next point. So next point, I'll say the specific heat of steam is equals to half of the specific heat of water is equals to specific heat of ice. You need to remember S specific heat of steam. Okay, that will be equal to S of water divided by 2. Okay, and that will be equal to S of ice. Got it? Yes. So you need to remember this very well because it is very helpful and you'll get it again and again and again. Right? So these are the simple formulas. So for here, let's say here it is given that 1 calorie per gram per degree Celsius for water, right? Specific it is given like this. So what will be for ice? So it will be half calorie per gram per degree Celsius. For steam, half calorie per gram per degree Celsius. Okay. So these are the simple things you need to remember. Okay. Let us move towards the next. Yeah. So here it is a question. Heat required to increase the temperature of 1 kg of water by 20 degrees Celsius. So I know one thing. Heat required. No, so delta Q is equals to M S delta T. Right. This is the simple formula I'm going to use. What is the value of mass? 1 kg. So at first I want to find it in CGS unit or SI unit. So let us find it CGS unit. So 1 kg means 1000 grams. So I'm writing 1000 grams. S is 1 calorie per gram per degree Celsius. So that is what 1 calorie per gram per degree Celsius. And temperature, change in temperature by 20 degrees Celsius. So here I'll write 20 degrees Celsius. So what I'll get? I'll just get 20,000 calorie. Right? This much energy is needed. So I can write what? 20 kilocalories. Okay. So this is a simple thing. You can do it, right? Okay. Next, if you want to find it in joule, right? So what you will do? A calorie is given 4 point. Yeah. So you can directly multiply with what? 4.2. Right? So you'll get in joule. So simple question, right? All of you can do it. Very simple. So let us move towards the next slide. Yeah, let us talk about this point. heat capacity, very important, very important. So let us talk about heat capacity. Listen, one thing, Q is equals to ms dt. Yeah, ms delta t. Let's say delta Q is equals to ms delta t. If I'll talk about some body, right? Let's say its mass is m, है ना? When we are talking about unit mass, okay, for unit mass, and it was specific heat, but I am talking about m mass, so I'll combinedly say m into s, right? So this is called what? Heat capacity. So heat capacity of a body of mass m can be written as C is equals to ms. Remember this, C is equals to ms. What was the unit of s? Unit of s was calorie per gram per degree Celsius. Sorry, calorie per gram per degree Celsius. So what I'll write for this C? C is equals to mass is multiplying. So calorie per degree Celsius. Okay. Or we can say what? Joule per Kelvin we can say. So this is a simple thing you need to remember. This is called heat capacity. M into S, mass of the body into specific heat of the body. So that is called what? Heat capacity. I think you are understanding everything, right? Yes. So let us talk about this properly. I explained you, but now I'll show you the theory. And now, yeah, first question we have already solved, right? What was that? Q is equals to ms dt, ms delta t. So here we can write what? Here we can write 1 kg means 1000 gram. S is 1 calorie per gram per degree Celsius into 20. So we are getting what? 20,000 calories means 20 kilocalories, right? Sorry, 20. This is the problem with this. Okay, kilocalories. Okay. Yeah. So this is a simple thing I wanted to explain you. Next, this point, right? Yeah. So let us talk about this point. Just a minute. Pen. Yeah. So heat capacity or thermal capacity. Its another name is thermal capacity. Heat capacity of a body is defined as the amount of heat required to raise the temperature of that body by 1 degree Celsius. So here I am saying if when we are talking about amount of heat required to raise the unit mass of body or 1 gram of body by 1 degree Celsius was specific heat. But here I am just talking about a body. The body of mass M. Its temperature we are rising by 1 degree Celsius, right? So that is called heat capacity. So let's say M is the mass of the body and S is specific heat. So we'll say heat capacity C is equals to M into S, mass of the body into specific heat of the body. That is called heat capacity. Remember these formulas, okay? Yes. So simple thing, I think you are getting very well, right? Just you need to remember the simple formulas, you can do everything. Okay, so here it is given unit of heat capacity, so that is calorie per degree Celsius. I already told you joule per Kelvin. You know why? Because mass is multiplying, so mass will cancel in the unit of S. Okay, so here I'm just saying calorie per degree Celsius or joule per Kelvin is unit of heat capacity. So let us talk about this next slide. Some important points, really very important. You need to mind it because many times in theoretical questions, like some options will be there and everything will be in theory. So you need to choose the correct option. So you must know that. Okay, sir, how 20 kilocalorie came? Oh, Kapil Kumar. Yeah. So here I already explained you the formula, right? The formula of heat was Q is equals to ms delta T, right? Yeah, so we know one thing, mass. Mass is 1 kilogram. So we are talking about CGS units. 1 kilogram is what? 1000 grams. You know? Yes. After that, specific heat. Specific heat is what? That is 1 calorie per gram per degree Celsius in CGS. So I am using that only. And change in temperature is 20. So we are getting what? 20,000 calorie means what? 20 kilocalories. So I think you got it, right? So let us talk about some important points. First important points, S is equals to Q upon ms delta T. This formula we already studied, right? So we are just talking about if change in temperature of the body is zero. Change in temperature of the body is zero. And I'll say what it is having, let's say some heat is given. After giving the heat, the temperature of the body is not changing. So I will directly say specific heat of the body is infinite. Specific heat of the body is infinite. When it happens, it generally happens when the body changes its state. Okay. Yes. So when body changes its state, means like it is ice to water, or we can say water to steam, right? So that time just there is the state of the body will change, but the temperature of body will not change. So that time I will say specific heat of a body will be infinite. Okay, remember this. So here this point is completely written. If yeah, so we know S is equals to Q upon M delta T if the substance undergoes the change of state which occurs at constant temperature. So I already told you temperature does not change, means temperature is constant, and S will be what? Q upon 0, so means it is infinite. Okay, thus the specific heat of the substance, then it is melt or boils, yani ki it is changing its state. Okay, so then it is called infinite. So simply remember, any body, right, is changing its state, means it is in solid form, so solid to liquid or liquid to vapor. So it is changing its state, and by the time its temperature will not rise, so we'll give it some heat and its temperature will not rise. So in that situation its specific heat will be infinite. Mind it, remember this. Okay, for theoretical MCQs. So next second point I'll talk, right? So whenever a body, okay, the body is not given a heat, body is not given any heat, but the temperature of the body is rising. For example, if you have some tea in a thermos flask, okay, or if you will shake it continuously, if you will shake it continuously, what will happen? Its temperature will light up, like it rise a bit, okay. So slightly it will rise. Why it will rise? It will rise just because of we are doing some mechanical work. We are shaking it. So we are doing some mechanical work, means we are giving it some no external heat is given, just work is done on it. Okay, no external heat is given on it because thermos flask is completely insulated, or no heat can be transferred through its wall. Okay, yes, so directly we'll say delta Q is equals to 0, so S will be equal to Q upon M delta T, means 0. Okay, so thus yeah, so directly we can say when equilibrium thermal flask is shaken, right, its temperature increases. Okay, so that time its specific heat will be 0. Yeah, so sir, complete fast, don't waste time. Okay, so theory per time waste. Okay, so I'll not waste time on theory. Let's move. Relation between specific heat and water equivalent. You should know what is water equivalent, because in many questions this term comes. Okay, let's say I have a body. So let's say this is a body. Okay, and this is water. Water. Let's say its mass is m, okay, m body, and its mass is m water. Okay, its specific heat is s body and its specific heat is s water. Okay, if I am giving some heat to the body, so I am giving some heat delta Q to the body, okay, and its temperature is rising by delta T. Same amount of heat I am giving to water also, and its temperature is rising by delta T. Okay, so same heat is given to body and same heat is given to water, and the rise in temperature for both body and water is also same. Okay, so in that situation the mass of the water, okay, that is called water equivalent. For example, I can write what? Q, delta Q for one is equals to delta Q for, like, delta Q for body is equals to delta Q for water. Okay, so I can write M body, S body, delta T. That will be equal to M water, S water, delta T. So delta T is same for both, cancelled, right? Next I'll say directly MW, that is M body, S body divided by SW. So this is called that is called water equivalent. Remember, minded this formula. Okay, yani ki amount of water which is required if the body and water both are given what? Same heat to rise in temperature by the same unit. Okay, yani ki like the same amount of rise in temperature by giving the same amount of heat. Okay, then the amount of water is called what? That is called water equivalent. Okay, so the proper definition is here, my dear friends. So the amount of water which required the same amount of heat to the same temperature rise as that of the object. Done. Right, yeah, my dear friend, now the sums will start, don't worry. Yes, so here I can say directly whatever I explained, the same thing, right? So MW is equals to MS. Okay, ms means mass of body, specific heat of body, divided by sw means specific heat of water. That's it. Yeah, so phase change. Let us talk about phase change, right? After that, we'll discuss some terms. Okay, so obviously, this is not a big chapter, this is small chapter only. So, heat required to change in phase or state, like uh, some ice is there, we are giving heat to it, and its state is changing from solid to liquid, it will become water. So, whatever heat is needed, right? Okay, so we'll talk about that heat, the heat required for the change of phase or state, right? So Q is equals to ml. That heat is what? Q is equals to mass into, this is called latent heat. L. L is equals to what? Q by M. So directly I'll say the heat required to change the state of unit mass of substance. That is called what? Latent heat. Okay. Simple definition. So I think you are getting it. So let's move a little faster. So directly I'll say the latent heat, the heat supplied to a substance, it changes its state at constant temperature. Yeah, so as I told, the temperature should remain constant. Okay, so temperature should remain constant. Okay, so it is called latent heat of the body. So at constant temperature, just we are giving heat to the body and state is changing. So for unit mass, that heat required is called latent heat. Okay, so now I'll talk about the latent heat. It is of two types. It is of two types. First, latent heat of fusion. Latent heat of fusion, and next latent heat of vaporization. So latent heat of fusion, when solid to liquid. A body changes from solid to liquid. Okay. And next I'll talk about latent heat of vaporization. So when a body changes from liquid, okay, from liquid state to vapor state. Okay. Yeah, we can say liquid state to gaseous state. So we'll say this is latent heat of fusion and this is latent heat of vaporization. So it is depending on change of state of the body or substance. So at first let us talk about latent heat of fusion. The heat supplied to the substance which changes it from solid to liquid state, okay, at its melting point. Like for ice, melting point is 0 degrees Celsius, right? And at 1 atmospheric pressure, the pressure is called, oh yeah, so what we'll say, it is called heat, latent heat of fusion. At 1 atmospheric pressure, unit mass of solid is converted into heat by giving some solid to liquid by giving some amount of heat. Okay, so I'll say that heat is what? Latent heat of fusion. Okay, and latent heat of fusion of ice, you need to remember it. Latent heat of fusion of ice is 80 kilocalorie per gram. So you need to remember, so per kg, है ना? Yeah, so just remember this value. So latent heat of fusion of ice, that is 80 kilocalorie per gram, or we can say 80 calorie per gram. That's it. So you need to remember this only. So let's move to the next slide. The latent heat of vaporization. What is the latent heat of vaporization? So I will say the amount of heat required to change the state of 1 gram of substance from liquid to gas. Okay, from liquid to gas at its boiling point. Yani कि at constant temperature and 1 atmospheric pressure we can say. Okay, so that is called what? That is called latent heat of vaporization. So you remember for water to gas, right? So its latent heat of vaporization, that will be 540 kilocalorie per kg. So we'll say what? 540 calorie per gram. So you need to remember this. Okay, 540 calorie per gram. Okay, so let us move towards next. Latent heat of ice, 80 calorie per gram or 80 kilocalorie per kilogram. Okay, so we can convert in joule. And we know what? 1 calorie is 4.2 joules. So let us multiply this. So we'll get this. Okay. Yeah. After that, let us talk about latent heat of steam. So latent heat of steam is 540 calorie per gram. So we can write 540 kilocalorie per kilogram. Okay. And let us convert in joules. So we will multiply it with 4.2. Okay. So we'll get 4200 into 540 joules per kg. So this is the simple thing you need to remember. Let us move towards the next. Next, I will talk about this. My dear friends, you can check this curve. Remember, this curve is very, very important. As we are rising as we are giving the heat to a body, you can see first its temperature from O to A, its temperature is rising. A to B, its temperature is constant. B to C its temperature is rising, C to D its temperature is constant, and D to E again its temperature is rising. So I am saying simply, let's say at 0, when its temperature was 0, body was at solid state. Okay, so I can say this is the slope, right? So temperature is rising. As the heat is rising, temperature is rising. So O to A, just its temperature is rising. I'll say it is solid state. Okay. So O to A, it is solid state. You need to mind it. Okay. After that, what is going on? Just a minute. Yeah. So at first I'll say O to A, it is solid state. This is solid state. Next A to B. A to B, what is going on? Just it is melting. So it is converting from solid to liquid. Okay, A to B, it will convert from solid to liquid. Okay, and this is melting point of the body. This temperature is melting point of the body. This is constant. Okay, so what will be the state of matter, right? Yeah, substance from A to B. So I'll say it will be mixture of solid and liquid. At point B, it will completely converted. It will be completely converted into liquid. Okay. So let us move. Next, I will talk about B to C. Means from this point to this point, B to C. So I'll say what? As we are increasing the heat, giving the heat, its temperature is rising. So at B it is water, at C it is steam. So I'll say B to C, what is, sorry, at B it is water, and at C also it is water, but its temperature is rising. Okay. So I'll say B to C it is liquid state and its temperature is rising. Okay. After that, C to D, it is what? It is just a horizontal line. Horizontal line means constant value. And constant value, we can say directly what? It is the state when it is the, like, it's this straight line is showing that the substance is changing its state from liquid to vapor. Okay, so whenever it is liquid to vapor, just its temperature is constant. So I am saying what? It is boiling point. Okay, and its temperature is just constant, and state is changing from liquid to vapor, and at point D it is completely in vapor state. Okay, and again I will say its temperature will rise from D to E. Okay, so yeah, now steam. Okay, temperature of steam is rising. So simply you need to remember, whenever you are getting a slope O to A, temperature is rising, means body is in a solid state. Okay, A to B, it is in what? It is changing its states from solid to liquid. B to C, temperature of the liquid is rising. C to D, so I will say just liquid is changing in vapor. And D to E, the temperature of the vapor is rising. That's it. The simple thing I wanted to say. Okay, so I think you got it. So here you can see what? Here you can see Q is equals to ms delta T. Okay, so I can directly write delta T upon delta Q is equals to 1 by ms. And I know one thing, mass is always constant. So delta T upon Q is proportional to S. And what delta T upon Q shows? It shows slope of TQ curve. Slope of TQ curve. So it just shows the slope of TQ curve, temperature and heat curve. So yeah, so let us talk about this. O to A and B to C. So let's say it is given that slope of OA is greater than slope of DE. Okay, slope of OA, this one, is greater than slope of DE. It is given. Okay, so what I will say, so slope is inversely proportional to specific heat. Okay, here it is given slope is inversely proportional to specific heat, 1 by S. So directly I will write here what? Directly I will write here S of OA. Specific heat of OA is less than specific heat of DE. This is the simple thing you need to remember. Okay. Yes. After that, I'll talk about this. Q is equals to ML. You all know this, right? So length of AB is greater than length of CD. So length of AB is greater than length of CD. This length is showing the amount of heat, right? So directly I'll say AB need more. Latent heat of AB is more and latent heat of CD is less. Okay, so just by this curve we can understand this. This is a simple thing you need to understand. So I'm asking one thing. Listen, a simple question is there in front of you. So let's say this is Q and this is temperature. So this is a curve in front of you. This is, let's say, point A. This is O, A, B, and this is C. Okay, let's say this is making 30 degree and this is making 60 degree. Okay, now the question is SOA or SBC, which one is greater? Which one is greater? This is the simple question. Okay. So I'll say slope of OA. Okay. Slope of OA. So that is how much? Tan 30 degree. And value of tan 30 degree is 1 by root 3. And I'll say slope of BC. The slope of BC is what? Tan 60 degree. And tan 60 degree is root 3. You all know that. So which slope is greater? So BC is greater than, you can say BC is greater than OA. So I will say slope BC, okay, is greater than slope OA. So here I'll say just inverse of that is specific heat. So it will be what? OA. है ना? OA is greater than SBC. SOA is greater than SBC. So simple thing you need to understand, right? Just I'll say what? The slope is inversely proportional to specific heat. Okay? Slope is more, specific heat will be less. Okay, so let us move towards questions. So now we are solving the questions as you people ask, sir, solve the questions. है ना? Yes. So let us solve the questions. Find the amount of heat released if 1 kg steam at 200 degrees Celsius converted into minus 20 degrees Celsius ice. So I'll say what? At first, it is what? It is 200 degrees Celsius steam. Okay, this is steam. Now what will happen? Steam will convert what? At first its temperature will come down at boiling point. So it will come to 100 degrees Celsius of steam. Remember, always temperature at first decreases and it comes to boiling point. Okay, so I will say it is steam at 100 degrees Celsius. After that, I am writing here Q1. Next, I'll talk about more heat is given. Let's say Q2 heat is given. So 100 degrees Celsius. Okay, this is steam. It will come to 100 degrees Celsius of water. Okay, now what will happen? Temperature of water will fall and it will come to 0 degrees Celsius of water. This is the process. Okay, one by one, step by step, it will follow like this only. Okay, at first temperature will fall, it will come to 100 degrees Celsius steam means at its boiling point. Now what will happen? Up, now its state will change. Its state will change from steam to water. Now the temperature of water will fall. Okay, after that, what will happen? Now the temperature of water is what? 0 degrees Celsius means it is its melting point. So it will change to minus 20 degrees Celsius. Minus 20 degrees Celsius, right? But before that, it is water now, so it will convert to 0 degrees Celsius ice, right? Yeah, here 0 degrees Celsius ice. And finally, it will convert to minus 20 degrees Celsius of ice. Remember, okay, yeah. So these are the different things you need to remember. So Q1, Q2, Q3, Q4 and Q5. These many steps you need to follow to convert 200 degree Celsius steam to minus 20 degrees Celsius of ice. So let us use this at first ms delta T. So m mass is how much? 1 kg, है ना? 1 kg. So directly I can write what? 1 kg means we can write here, let's say 1000 grams. Okay, S is how much? So S is 1 gram. Yeah, for steam it is 1 by 2. है ना? 1 by 2 gram per degree per Celsius. Yeah. So next delta T. So delta T is how much? Final temperature is 100 and initial is 200. So final temperature minus initial temperature. I will write what? 100 minus 200. Okay. 100 minus 200. So I am getting minus 100. Okay. So directly I'll get here what? I'll get here 1 by 2 means 0.5. And 0.5 into 10 power. How much? 1, 2, 3, 4, 5, 10 power 5. Or here negative sign. So this is Q1. Let us talk about Q2. So I know Q2. Q2 means here the state is changing. So that is M into latent heat of vaporization. Why? Because here the state is changing from steam to water. So steam to water it is changing. I will say heat will release means it will be negative. Remember, whenever heat is releasing, it will be negative. So I'll write what? Q2 is equals to minus M. M means 1000 gram and L is 540 because I am taking SI units. Okay, so 1000 gram into 540 calories. So you need to remember this 54. Okay, and 0, 0, 0, 0, that much. Okay, so that much heat. Okay, what next? Next, water. 100 degrees Celsius to 0 degrees Celsius. So I will say directly Q3 is equals to ms delta T, m 1000 gram. S for water is 1 and delta T. Finally 0 degrees Celsius, initially 100. So 0 minus 100. Final temperature minus initial temperature. So that is minus 100. So directly I will say what? 10 power 5. Okay. 10 power 5. Here also we can write what? 1, 2, 3, 4, 5. So 5.5. Sorry, 5.4 into 10 power 5. We can write it like this. Okay. Yeah. So this all are in calories. This is also in calorie. This is also in calorie. Okay. Let us talk about Q4. So Q4 we can say what? 0 degrees Celsius water to 0 degrees Celsius ice. So directly I am into latent heat of fusion. But we need to use minus sign. Why? Because heat is released. Water to ice. If it is ice to water, heat will be absorbed. It is water to ice, so heat will be released. So minus of 1000 gram into latent heat of fusion. So latent heat of fusion is how much? 80. So directly we can say what? 0.8 into 10 power 5 calories. Okay, simple, right? 80,000 simply are. So we can say what? 0.8 into 10 power 5. Okay, let us move to the next Q5. What can I write here? So here, yeah, here directly I can say what? Its temperature is decreasing, है ना? So I will write what? ms delta T. M means 1000. S means for ice it is 1 by 2. For delta T. Delta T final temperature is minus 20. Initially 0. So here minus 20. So directly I will say what? Minus of 10,000. Okay. So I'll write minus of 10 power 5 calorie. So these are the things we need to remember. Okay, directly let us use it. What will be the final heat? Hai What will be the final heat? So I'll write here. We need to add this all. So what we'll do? We'll add this all. Q total. Q total, that is Q1 plus Q2 plus Q3 plus Q4 plus Q5. This all you need to remember. Okay. So here directly we can say 10,000 means you can write 1 into, yeah. So here you can say 0.1 into 10 power 5. Okay, 0.1 into 10 power 5. You just need to add this all and you will get the final heat. That's it. So this is the simple question. You can do it. Okay. This is the simple question. You can do it. Steps you need to remember. Okay. Just steps you need to remember. So I think you got it very well. So I am erasing this, right? So I'm going to delete this all. So here let us talk about this. Let's say it is given minus of x degree Celsius ice. So what will happen? Minus x degree Celsius ice. Q1 will say that is m in, yeah, ms delta T. Okay. So it will come to 0 degree Celsius ice. Okay. I'm just repeating the steps. That's all. After that its state will change. The Q2 is equals to m into LF. Okay. Yeah. So what will happen? It will come to 0 degree Celsius of water. What is the next step? Now water, the temperature of water will rise. I'll say it will come to 100 degrees Celsius of water. Okay, so this is Q3 and that is ms delta T. After that what? 100 degrees Celsius water, its state will change. So it will come to 100 degrees Celsius of 100 degrees Celsius of steam. Okay, here Q4, that is M into LB. You need to remember. After that, what will happen? Its temperature will change. So it will be what? Q5. So it will come to, let's say, some Y degrees Celsius of steam. So these are the steps you need to follow. Okay, that's it. So let us talk about the calorimeter. What is calorimetry and what is calorimeter? Very important concept, calorimeter and calorimetry you need to know. So let us talk about calorimeter. The branch of thermodynamics which deals with measurement of heat is called calorimetry. I already told you. Okay. Branch of physics which need to, which deals with the measurement of heat is called calorimetry. So this thing you need to remember. After that, we'll talk about the calorimeter. So what is calorimeter? Let me talk about this. A calorimeter is just a device. Okay. So how it is, let's say it is a wooden box. It is a wooden box. Inside it a copper vessel will be there. Okay, why this is insulating chamber. Insulating inside this is made of copper. So inside this one is copper. It is made up of copper. Okay, now what will happen in this chamber? there will be a thermometer. So there will be a thermometer. Okay. So I will write this is thermometer. Okay. What next? After thermometer, what next? One will be here a stirrer. So this will be a stirrer. Okay. Yeah. Why it is used? So inside it some material like water will be there. Okay. And this water is at some temperature. Now I know an unknown substance. So I will add unknown substance into it. Okay. And I'll check how much time it is taking to change its temperature. Okay. So what will be the final equilibrium temperature? So using that we can find what we can find the final temperature. We will not initial temperature we know, so finally we'll find the unknown. Okay, specific heat of unknown substance. So calorimeter, okay, it is a device or instrument, we can say. It will find what it is used to find specific heat of unknown substance. Okay, so whatever I explained, that thing only written here. So already you will study this thing in NCRT or your school syllabus. So I don't need to talk about its description. Just remember what inside it water is there, copper is there, and unknown substance is there. These three things are there. We need to remember. Okay. And using these three, we used to find the specific heat of unknown substance. So we'll solve some question based on this later. So the most important topic of this chapter, that is law of mixture. Okay, so let us talk about law of mixture. What is law of mixture? When two substances at different temperature. So I'm just talking about this law of mixture. Okay, yeah. So law of mixture is what? Let's say I have one substance. Its temperature is T1. Okay, I'm just mixing it with another substance having temperature T2. And I'll mix this both. Okay. Let's say its mass is M1, its mass is M2. So in the final mixture, I'll just say its temperature is T. Both the substances are there, yeah, both the liquids are there in the mixture, and the final temperature is T. And this T is the equilibrium temperature. This T is the equilibrium temperature, because at last, at final, this entire substance will come at thermal equilibrium. Okay, yeah. So we will just consider ki when we mix two substances, two liquids, there will be no loss of heat. Okay, there will be no loss of heat. So sum of change of heat should be zero. This is the law of mixture. Okay, sum of change of heat should be zero. Okay, that is the simple thing I wanted to explain you. That's all. Okay, so let us understand this. Okay. Yes. So I am saying key when two substances. So here you can see in the diagram M1 S1 T1. Okay. This is one substance. Its mass is M1. Specific heat is S1 and temperature is T1. After that it is mixed with another substance M2 S2 T2. Mass is M2. Specific heat is S2 and temperature is T2. Both are mixed. Then the final temperature of the mixture will be Tm. Final temperature of the mixture will be T mixture. So how I'll solve it? So I will say, let's say exchange of heat in the first is Q1, exchange of heat in second is Q2. Q1 plus Q2 should be equal to 0. So directly I'll write what? M1 S1 final temperature Tm minus initial temperature T1. Okay, plus M2 S2 final temperature is Tm minus initial temperature is T2 is equals to 0. This should be 0. So as we'll solve it, let us send it to RHS. So what we'll get? M1 S1 Tm minus, yeah. So what I can write, Tm minus T1. Okay. If you send it to another side, okay, so it will become negative. So let us take negative sign inside. So it will become M2 S2 T2 minus Tm. T2 minus Tm. Just remember this. You can write, yeah, both are same only. Okay, this one or this one same only. Okay, you'll get the same answer. So I think you are getting it. Okay, laws of mixture means change in heat in first substance will be equal to change in heat of second substance. Okay, so or you can say what, Q1 plus Q2 is equals to 0. Net change in heat will be 0. Why? Because there is no loss of heat. So this is only the law of mixture. Okay, so we'll solve the question based on this. So let us solve this question. Three different liquids of different masses and different specific heats and different temperatures are mixed. So let's say I'm saying ki one is M1 S1 T1, second is M2 S2 T2, second liquid, and third liquid is M3 S3 and T3. These are three liquids. Okay. Now what I'll do is I'll just mix three. This three I'm going to mix. Okay. This three I am going to mix. So in the final mixture, what will be there? I'll say M1 will be there, S1 will be there, M2, S2 will be there, M3, S3 will be there, M3 and S3 will be there. I'll just consider this three liquids do not react with each other, and final temperature will be T. This is temperature of the mixture. So what I'll say, here exchange of heat is Q1, here Q2 and here Q3. Okay, mind it, Q1 plus Q2 plus Q3 should be 0, right? This is the law of mixture. So I am using here M1, S1, final temperature minus initial temperature. This is delta T. So T minus T1. Okay. Plus M2, S2, M2, S2, final temperature minus initial temperature. So T minus T2. Okay. And now I'll write Q3, that is M3, S3, final temperature T minus T3. Okay. Final temperature minus initial temperature. So that will be equal to 0. Okay, my dear friends. So that will be equal to what? 0. So now what I can do? I need to find the value of T. So I will write M1 S1 plus M2 S2 plus M3 S3 into T. That will be equal to M1 S1 T1 plus M2 S2 T2 plus M3 S3 T3. M3 S3 and T3. Okay, M3 S3 T3. So what final answer I'll get? So final answer I'll get T is equals to, very simple. You can see M1 S1 T1 plus M2 S2 T2 plus M3 S3 T3. Okay, so what final answer I'll get? I'll get divided by this M1 S1 plus M2 S2 plus M3 S3. Yes, so this is the final answer we'll get. Okay, so based on this, let us solve the question. Okay, so next question is iron block. My dear friends, iron block of mass 2 kg fall from a height of 10 meter. It is falling from a height of 10 meter, and after colliding with the ground, it loses 25% of energy to surrounding. Okay. Then find the temperature rise of the block. What is the rise in temperature? You know? Yeah. So what I am saying, after colliding, as it will collide, 25% heat it will lose. Okay. Yeah, and where it will go to surrounding. Okay, so let us talk about this. So I am saying what is the change in energy. So I'll say work done by gravity, that is equal to change in potential energy. So that is how much? That is, I'll say directly what? ms delta, sorry, mgh. It is falling from a height, so 2. Okay, and I am just writing it, uh, 2 into g into h. So that is g into h. H is 10 meters, so I will say directly it is 200 joule. Okay, yes. So how much part of it is went into surrounding? Okay, yeah. So in surrounding is 25% energy it is losing. So 25% is going into surrounding. So I am saying ki just 25% whatever energy is lost. Okay, that is went into surrounding in form of heat. So I will directly say what? 25% of delta U, that is equals to what? Heat. So directly I will write here what? 25% means 1 by 4, okay, into mgh, and that is equals to heat. Okay, so that will be equal to heat. So directly I'll get here what? Value of heat is 200 into 1 by 4. Okay, that is 50 joule. So let us convert into calorie. 1 joule is 4.2 calories. So 50 into, yeah, 4.2. This is what in joule now, so we can convert it, right? We can directly convert it. So divide by 4.2 calorie, and now this is in joule, so we need to convert it properly like that. Yeah, what is joule? All of you know, right? We can directly convert it. You can do it directly. You just what you will do, joule to calorie, you can convert it, divide by 4.2. Answer. Okay. So next, temperature of, yeah, my aim was just to explain you the concept. Okay, if you are understanding the concept, that's enough. Calculation you can also do. Let us save the time. Next, I'm talking about this, the temperature of equal masses of three different liquids. Let us talk about three different liquids: A liquid, liquid B, and liquid C. There are three liquids. Okay. Yes, its temperature is given first 10 degrees Celsius, its temperature is given 15 degrees Celsius, and the third one is of 20 degrees Celsius. Now, what will happen when they are mixed? Okay, the temperature of A, B, and C are mixed, and it will become 13 degrees Celsius. Oh, sorry. It is given A and B are mixed. If A and B are mixed, okay, so their temperature will become 13 degrees Celsius. Now, if B and C are mixed, so B and C are mixed, then the temperature will become 16 degrees Celsius. My dear friends, very, very good question, okay? Yes. Now, what will happen? If A and C are mixed, then find the final temperature of the mixture. So, I will say for A, let's say this is S1, specific it is S1. For this S2, okay, for B specific it is S2, and for C specific it is 3. Okay, now what I'll do, I'm saying ki here heat is Q1, here Q2, here Q3, and Q4. Okay, so I know the law of mixture. From the laws of mixture, I'll say what, Q1 plus Q2 should be equal to 0. Okay, Q1 plus Q2 should be equal to 0. So directly I'll write here, yeah, equal masses, all are having same masses. So I will write M S1. I'm just talking about this Q1. Q1 means change in temperature of A. You know? So I'll write final temperature is 13, or initial temperature was how much? 10. So 13 minus 10. Okay. Plus Q2. So Q2 I'll write M S2, or its final temperature. Its final temperature is how much? Final temperature is 13 and initial temperature is 15 is equals to 0. This is the law of mixture. So I'll get what? M cancel, है ना? Because that side is 0. So I am taking M common. Okay. So M I am taking common. So this is 3S1 minus 2S2 is equals to 0. So directly I got a relation. What? 3S1 is equals to 2S2. This is equation number 1. Remember equation number 1. Now what's going on? I am mixing B and C. So it is coming from A plus B. Okay. Now I am talking about B plus C. From B plus C, what will happen? So I'll say Q3 plus Q4 is equals to 0. Okay. So let us use this. I'll say M S2, and final temperature is 16 minus initial temperature is 15. Okay. Now plus M S3, final temperature is 16 and initial temperature was 20. Okay. Yes. And sum of this both should be what? 0. So from here directly I'll get what? S2 is equals to how much? 4S3. So I got two relations simply, right? Yeah. So I can find everything in terms of S2. You know? So this is equation number 2. You need to remember. Okay. So from here, what relation we are getting? So from 1, है ना? We are getting S2. Sorry, S1. S1 is equals to 2S2 by 3. 2S2 by 3. Okay. From 2, from equation number 2, we are getting S3 is equals to S2 by 4. Just these two things we need to remember for solving its further part. And further part is, if A and C are mixed, what will happen? Okay. So let us solve it. Now what I am going to do is, let us mix A and C. Okay. So temperature of A was how much? Let me see. That is 10 degrees Celsius. So 10 degrees Celsius, and temperature of B was 20 degrees Celsius. And these two are mixed. What will happen? So I will say this is, let's say, Q5 and this is Q6. Its specific heat, I know specific heat of A is what? S1. This is from calorimetry. Nargis, this is from calorimetry. Okay. Calorimetry. Yeah. Now the temperature of C is changing. So I am saying its specific heat was S3. So final temperature, let us consider T. Okay. So what I'll say, key laws of mixture. From the laws of mixture, it is a 12 board syllabus. Beta, it is in NEET. It is in 12 board syllabus also. It is okay. Remember. So directly I will say what? Q5 plus Q6. Okay, sum of both, that will be what? 0 from the laws of mixture. So directly I'll write what? M. Okay, Q5 is changing a change of heat of A. So I will say what? S1 and delta T. Final temperature is T, initial temperature is 10. Okay, plus now let us talk about Q6. Q6 is what? Change in heat of C. I'll write M. S3, final temperature is T and initial temperature is 20, is equals to 0. Okay, that's all. So I'll say M is common and cancel, it is gone. So directly here I will write, because in the last slide we have derived S1 is 2 S2 by 3. So how much S1? S1 is equals to 2 S2 by 3. Okay, and S3 is equals to S2 by 4. We derived this, okay, in the last slide. So let us put the value. Here I'll write 2 S2 by 3. Here I'll write T minus 10. Okay, plus put the value of S3, that is what? S2 by 4. Or here I can write T minus 20 is equals to 0. So let us take S2 common. So S2 will be common and cancel. Okay. Now what we need to do, just take the LCM and solve it. So I'm going to take its LCM. So what I'll do, I'll take LCM. So I'll get divide by 12. Okay. So not needed. Here I'll write 8 T minus 10. Okay. Plus here 3 T minus 20. So 3 T minus 20. I'm just taking LCM and solving it. Okay. Nothing else. Is equals to 0. Actually divide by 12. So that will go in 0, right? Cross multiplication. So what I'll get? Directly I'll get 8T minus 80 plus 3T minus 120. Are you getting what is this? 3 into 20 is what? Sorry, 60. Yeah. 60, not 120, it is 60. It is 3 now, so 60 is equals to 0. So what I can write finally, I can write 11T. Okay, 11T is equals to 140. Okay, so what is the final answer? Temperature, final temperature is 140 by 11 degrees Celsius. This is the final answer, my dear friends. This is the final answer. So this was, so what about vector continuation? Yeah, vector continuation, I'll give one lecture tomorrow. Okay, so one lecture will come tomorrow for vectors, don't worry. And one lecture will come for this thermodynamics. Okay. So directly we are getting here 140 degrees Celsius divided by 11. Okay. Now I guess you are in 11th class or 12th class. So let's talk about this question. 1 kg of ice at 20 degrees Celsius minus 20 degrees Celsius is mixed with 1 kg of steam. Very, very important question. Listen, my dear friends. Ice at minus 20 degrees Celsius is mixed with steam. So here is the steam, or it is at 200 degrees Celsius. How to solve such type of question? Okay, so here what I'm going to do is I'm just going to solve it simply. Two substances are mixed, means ice at minus 20 degrees Celsius is mixed with steam at 200 degrees Celsius. Okay, and the question is, find the equilibrium temperature and final content of mixture. Means finally what will be there? There will be steam and water and ice. What will be the final substance remaining? Okay, so I am just talking about this ice. So I am just saying the ice is converting into at first 0 degrees Celsius ice. So how much heat is required? So I will write here Q1. What I'll write? Q1. So Q1 is ms delta T. So mass is how much? Mass is 1 kg, means 1000. Okay. S. S is how much? 1 by 2 for ice. And delta T. Final temperature minus initial temperature means minus 20. Okay. Final temperature is 0. Initial is minus 20. So what I'll write? Minus minus, yeah. So 5 minus minus plus हो जाएगा, right? How I'll write? 0 minus of minus 20, like this. Change in temperature, final temperature minus initial temperature. So what I am getting here? I am getting what? 10,000. 10,000 calorie. This is the first heat. Next, let us talk about this. Now 0 degree Celsius water is 0 degree Celsius is what? Ice. So ice is melting and coming to 0 degree Celsius of water. Okay. Yeah, so this topic 12, sir. No, this is in 11th. Okay, this thermodynamics. Okay, so thermodynamics, simple chapter. So I will talk about this 0 degree Celsius of water it is coming. So I'll write heat is Q2. Okay. And Q2 can be written as M into latent heat of fusion. Mass is 1000 gram. Latent heat of fusion for ice is 80. So I'll write what? 80,000 calorie. My dear friend, 80,000 calorie. Okay. Let us talk about the steam. What will happen with steam? If I'll put ice into steam, so temperature of steam will fall down. Because this is Tejas, this topic is calorimetry. Okay, it is part of thermodynamics. Okay, thermal physics. It is the part of thermal physics. This is called calorimetry. And in calorimetry, we are talking about laws of mixture. So if you want to understand, you need to see this chapter from starting. Okay. Yeah, you are appearing 2021 or 2022. So steam. Okay. So for steam, I'll write here what? Yeah, for steam, I am just writing here. Let's say its temperature is falling. It is at first it will come to 100 degrees Celsius of steam. Okay, 2021. Then it is important for you. Okay, 100 degrees Celsius to steam. Okay, yeah. So if you join in between, definitely I think you will not understand it properly. You need to see it from starting only. So here I'll write Q1 dash. Okay, what I will write here? M S delta T. Okay, so what is the value of M? M is yeah, 1 kg of steam. So 1000 gram. S for steam is 1 by 2 and final temperature is 100. Initial is 200. So final is 100. Initial is 200. Final minus initial is minus 100. Hai na? So here I'll write what? Minus 100. Okay. So finally I will get what? 50. Right? 1000. So minus 50,000 calories I am getting just by changing the temperature. Okay. Right. What next? Here you can see 1000 plus 80,000. So now it is 90,000. So let us talk about the other side. I'm just changing its, yeah, here how much heat is needed. So let us talk about its change in state. So I will write here Q2 dash. Okay. Actually, we need to analyze both the sides simultaneously. Then only we can solve this question. Else not. So Q2 is equals to mass M and here latent heat of vaporization. Because its temperature will fall, so we'll write it negative. Okay. I'm just saying let's say M mass of this will fall. So M mass, so minus of M and this is, yeah. So what is the value of M? You all know that is 1000 grams. How much? Yeah, let me erase it. So if I talk about this, if I talk about this, I will simply say it is 1000 grams. Okay, it is 1000 grams. And what is the value of LV? That is 540. And here negative sign because its state is changing from steam to water. Okay, steam to water. But I don't know how much water will convert. That's why I'm writing just M here. Okay, just writing M here. Let's say M mass will convert from steam to water. Okay, so let us talk about this. I know here steam and ice are in equal amounts, है ना? And latent heat of steam is very large, 540, and latent heat of ice is very less, 80. So I know one thing: entire ice will convert into what? The entire ice will melt and it will reach to the 100 degrees Celsius temperature of water. Okay, so now I am just changing its temperature Q3. Q3 is equals to ms delta T. So ms delta T मतलब 1000 into 1 into delta T, 100 degrees Celsius it is going. Okay, so 100 degrees Celsius. So what will be the value? So this will be 100,000. Okay, yeah. So calories. What should happen? Finally, yeah, some M mass is melting and final temperature is 100. So I will just talk about this here. The final temperature of mixture is 100 degrees Celsius. What? Final temperature of mixture is 100 degrees Celsius. We just need to remember. Actually, this is a little difficult, but you need to understand it. Okay. So I'm saying final temperature. Final temperature is 100 degrees Celsius. Okay. Okay. Now I'll say what how much steam will convert into water. So I'll write sum of all heats Q1 plus Q2 plus Q3. okay, plus q1 dash, q1 dash plus q2 dash, okay, plus q3 dash. These are the heats. So sum of this all should be 0. Here you can see, yeah, there is not q3 dash, there is q2 dash only. So let us not write this. Yeah, so let us write it sum. Okay, let us write it sum. So it's sum q1. Q1 how much it was? 10,000 and 80,000. So I'm writing here 10,000 plus 80,000 plus this q1 dash, sorry, q3 was 100,000. Okay, plus q1 dash, that was 50,000. Okay, 50,000, and plus this q2 dash, q2 dash was just m into 540. I don't know how much is its value. I'm just writing 540 is equals to 0. Just simply laws of mixture I'm going to use here. So directly what we'll get here, let us, yeah, this was negative. This was negative. So what we are getting, 60 and this 140, 140,000. Okay, 140,000, that will be equal to m into 540. M into 540. So we will just divide. Okay, so here we'll get 140,000 divide by 540. So 1010 cancelled. 54 will divide in this. Okay, as we will divide this all, what, 140,000 divided by 50 will get the value of mass. What will get? Will get the value of mass which is converted into water. Okay, so it will give the value of mass. Okay, mass of steam converted into water. Converted into water. So this much of steam, what will happen? It will become water. Okay. So just need to do the simple calculation. As you will solve it, you will get the value. Okay. Yeah. So if you will solve it, what you will get? Yeah. So you can write 14 kg. 14 kg divided by 54 calorie. 14 kg divided by 54 calorie. Okay. So here you can write 7 by 27 kg per calorie. Sorry. Sorry, just kg. Okay. Yeah, else everything is solved, right? Everything was in calorie. So we don't need to write here calorie. Just simply we are converting it, nothing else. So 14,000 can be written in kg, right? So 14 kg divided by 54. So here we are getting 7 by 27 kg. Okay. This much of steam will convert into water. So finally what we are getting? Total amount of water. So what will be the water? First, entire ice is melted. So 1 kg water plus 7 by 27 kg water. So total water is how much? Let us add this both. So we'll take LCM and we'll add it. So we'll get what? 34 by 27 kg is total water. And now the question is, how much is ice? Sorry, how much is steam? Ice is 0. Ice is not there. Entire ice is melted. So how much steam is remaining? So I'll say 100, sorry, 1 kg of ice was there, steam was there. How much steam, 1 kg was steam was there, and m mass is melted. So 1 kg minus m. So directly I'll write 1 minus 7 by 27. 7 by 27. I'll get 20 by 27 kg of steam will remain there. Okay, of steam will remain there. So this was the question. Definitely it is little difficult, but you need to understand. You need to move parallelly and you need to compare the heats. Okay, yeah, we got it. So let us talk about, yeah, so let us finalize this chapter. This chapter is ended. So I will simply say that this was a chapter which is just questions and calculation based. We can bring more questions, but not here. I will bring the questions on Unacademy app in my special lectures that is free for you, and that is, yeah. So that will be interesting because there will be polls and you can participate in the polls. If you will participate, it will be very interesting for you. So I'm just simply saying key, if you want to cover entire syllabus with my help, use my code RAHULD, RAHULD, and buy the Unacademy subscription. If you buy the Unacademy subscription, you get the India's best educators, India's top educators, and you can cover the entire syllabus. Okay, so I'm saying ki, to get something good, you need to invest money. For example, in a business, if you do not invest money, you will not get benefit. You cannot get benefit. You cannot get final profits, right? So, if you want profit, you want to learn, you need to get the Unacademy subscription. So use my code Rahul D and get Unacademy subscription. And please click the bell icon and subscribe our channel. So thank you. Bye bye for today.